Alright, we have a question in this way which says, what is the dimension of each of the following quantities? Velocity ratio, mechanical advantage, coefficient of friction, tensile strain. Now looking at each of these, there is something common with each of these items. Each of these quantities, okay, let's start with this. Let's start with velocity ratio. Velocity ratio VR is given by what? Distance moved by the effort over distance moved by the load. Distance by effort is measured in meter. For this, it's also in meter. So comes one. You can say it has no. You can say it has no units. What is the ratio? Yes, the ratio. The same thing applies to this. Mechanical advantage is load over effort. So load over effort. Load is in Newton, effort in Newton. They'll cancel one, no units. How about this? Coefficient of friction. Mu. The cost of frictional force over number of reaction. This is Newton, this is also in Newton. This will cancel out. Or how about this? Tensile strain. Tensile strain. Epsilon. That is extension of our original length. Extension is in meter, length in meter. This will cancel out. So in all this, they have no unit. But let's find out if they have dimension. For velocity ratio is equals to distance by effort, distance by load. Dimension for distance is L. For this one it is also L. So the dimension is 1. We do that for mechanical advantage. Mechanical advantage, load over effort. Dimension for load is same as that of force, which is MLT minus 2. The same thing here, MLT minus 2. So that is equals to 1. If we do that for this and this, you also get 1. So in summary, for any quantity that has no unit or as a ratio, the dimension is always 1. It's always 1 and not 0. So this is wrong. This is wrong. This is also wrong. This is also wrong. This is wrong. And this is the correct answer. Yes. That is the correct answer. So the dimension of any quantity that has no unit as a ratio is equals to 1. Thank you and see you in the next video.